Hi everyone, the purpose of this video is to get you ready for the formal lab number 1. You'll have 2 weeks to complete this lab, and I am starting you a week ahead of the lecture class, and so to help you get started, I'm going to go through what is a solution, what is molarity, and how do you make a serial dilution. This lab is going to occur in your own kitchen, and you'll end up with something that looks like this picture, in that you're going to make 5 different concentrations of solutions, and at the end you're going to have color which will show that you have indeed changed the concentration. But you're also going to do the calculations to support what your concentrations are in your 5 solutions. So this lab will involve doing something in your kitchen and videotaping that and explaining the steps you took, and also explaining your calculations. You also will submit a formal lab report. Alright, so the goals: create a set of standard solutions using everyday materials. Standard solutions means that you know the concentration. Everyday materials, most people will use Kool-Aid or cocoa or Miracle-Gro. And to get to moles, which is the crucial piece, you will have to make some assumptions. For instance, if you're going to use Kool-Aid, you're going to assume that it's almost all sugar, and so you'll use the molar mass of sugar to do your calculations. If you use Miracle-Gro, pick a main ingredient and say it's all that, and so that you can get a molar mass. You'll have to do something like that to get going with moles. You will calculate concentrations, and I'm going to show you how to do that in just a moment. Creating a video any number of ways, with your iPad, your phone, any way. It will be peer reviewed. There is a template to help you write the report, and the peer review will occur the following week. So first of all, I'd like to introduce you to the idea of a solution. To a chemist, the solution doesn't mean the answer to a math problem. To a chemist, it means a mixture, a homogeneous mixture. And so if you have a flask of salt water, the salt, let's say it's sodium chloride salt. Salt is just a general term for any ionic compound. So this salt, it's the minority thing, and so it's the solute. And water is the majority thing, and so it is called the solvent. And that's the general terminology that you need to become familiar with. The solute is the minority thing. The solvent is the majority thing. And the total is the solution. When we have solutions, I'm showing you a liquid solution, and that's probably most common. But you can have a solution of gases. Air is a solution because it's a homogeneous mixture of nitrogen and oxygen and helium and other gases. A solution can be a solid. It can be like white gold is silver and gold mixture. It's homogeneous. And the minority component would be the solute. So let's go through. There are lots of different ways in which chemists express the concentration of the solute in the solvent, but the main, most important way of expressing concentration is molarity. And molarity is defined as the moles of solute over liters of solution. I abbreviate solution SOLN. Alright, so let's practice with this. Let's suppose this is our solution. Sodium chloride has a molar mass of 58 approximately. Okay? So let's say you're asked the question, what is the molarity of a solution composed of 20 grams NaCl in 250 milliliters of water. Well, let's do what it says. It says moles of solute on the top. Well, let's get that. Okay, let me change pen colors. Let's do more mountain right here. Okay, 20 on the top, 58 in the lower right. How many moles is that? 20 divided by 58. 0.34 moles of NaCl. That's our numerator. Our denominator is liters of solution. Now we have 250 milliliters of water. How many liters is that? I hope you're thinking that's 0.25 liters. We are going to ignore the volume of the salt itself. I don't have any data on that here, so let's just keep our life simple at this point and say the solution volume is pretty much the same as the water. So 0.34 divided by 0.25, we would say this is a 1.4 molar salt solution. Okay, and we write it like that with big M. I only really have one sig fig, but I'm just trying to show you the process here. Okay, so let's talk about dilutions now. So I'm now moving on to a key idea you have. You're going to start by making what we call the mother solution, the first solution, establish its concentration, and then you're going to dilute it 4 times and calculate the molarity of the offspring of the daughter solutions. So let's look at this. This would be my starting point, 1.4 molar. What you're going to do in this lab is you're going to take a carefully measured volume of this salt solution and you're going to transfer it over to this new flask. Well, you probably won't have flasks at home. You'll probably have cups. And that's one of the things you need to approximate, is try to get a volume as best you can. All right, let's say I transfer 10 milliliters of salt water, and I'm going to add, let's say 90 milliliter. I don't want to use 90. That's too easy. 85 milliliters of water. What is the molarity now? The molarity, or the dilution equation, is going to be super helpful to you. So let's put the dilution equation up here. It's M1V1 equals M2V2. Big M are the molarities. V are the volumes. All right, I'm asking you, what is the new molarity? So that's going to be the M2. So let's put the numbers in. The first molarity we established was 1.4 molar. The volume of that solution that I'm taking, we transferred 10 mils. Whoops. That's a 10. So I took 10 mils of that. Now, the units you use for molarity, for volume, just be consistent on the left and right because they'll cancel each other. M2 is your goal, is to get that. That's your X. And V2 is 95. Okay, and so what is the answer? It would be 14 divided by 95. It's 0.15 molar equals M2. So that makes sense, because if I had put 90 here, or 10 in 100, so that would have been a tenth, but I'm a little less than that, so it's a little bit more than 0.14. Alright, so that's how you do a serial dilution. So you would then take from this one and form the next daughter solution. So let's say we take 20 mils this time, drop it in here. So we have 20 mils of the 0.15 molar, and you add a new quantity of water to it. Alright, what would the new molarity be? M1V1 equals M2V2. What's M1? Hope you're thinking 0.15 molar. What volume did I take? 20 mils of it. Here's my X. I don't know the new molarity, but I know that I have 90 mils of it. And so it's going to be 0.15 times 20. That's 3 divided by 90. 0.033 molar. And so what I challenge you with in this lab is, can you get all the way down to 0.000001 molar? That's a part per million. And can you get down that low? Sometimes chemists need to reach those low levels of detection. Alright, well, thank you very much for your attention, and good luck with the lab. Ask me questions if you're having troubles. Thanks.